Remote control is the easiest way to access almost all actor properties. However, working with remote control presets can sometimes be cumbersome, and the overall workflow takes some getting used to. In addition, remote control does not allow us to intervene in the data flow or execute custom blueprint logic. This is where the Lumia Consumer component comes into play. With Lumia Consumers, we can lumify our own actors and execute blueprint logic directly in the editor, similar to LiveLink. This opens up entirely new possibilities, and with a FlexGraph asset, we can even modify both the data routing and the data itself. Let's start with a simple example. We create our own actor. Using the Lumia Simple Actor class as a base, this immediately gives us a Lumia-ready actor and allows us to implement custom blueprint logic. Once the actor is created, we can see the Lumia settings in the inspector. The first step is to define which data channels we want to respond to. Lumia tags every incoming data packet with a gameplay tag. To filter the data, we simply specify the gameplay tags we want to listen to. These filters are defined in the input tags property. They can be entered manually or, much more conveniently, set automatically using the learn function. The learn function does more than just set gameplay tags. It also configures data channel specific string filters. For example, with MIDI, we can define exactly which device, which channel, and which MIDI CC message we want to respond to. To do this, we first activate Learn mode. If we want to capture multiple data sources, we also need to enable Input Learn Additive. Otherwise, each new input would overwrite the previous filter. In the input data field, stated we can see the filtered data that is currently received by this actor. To analyze and refine this further, we can use the channel data section. Here, the data is separated by channel, allowing detailed monitoring and fine-tuning of the string filters. The learned filters can be modified manually, although in most cases, the automatically generated values are sufficient. For example, we can use a wildcard or regular expression in the device name field. If we enter an asterisk, the filter will react regardless of the controller, as long as the channel and data values match. The live data display is primarily for monitoring and shows incoming data, even if it would normally be filtered out. If the Notify Owner option is enabled, the filtered data is sent in real time to the On Lumia update event of the actor. Let's verify this in the blueprint graph. Here we can see the custom event node. By splitting the data pin, we gain access to the individual data channels. Now, for example, we can promote the MIDI data to a variable and monitor its values. As you can see, right, we can now work with the data directly in the editor and without entering play mode. To demonstrate this in practice, let's look at the Lumia level sequence actor. I already have a fully configured setup here. When I move a slider on the MIDI controller, you can see that the pedestal moves. This movement is driven by a level sequence. If we open the sequencer CEU, we can see that the slider is effectively controlling the timeline. This allows us to drive complex animations with a single input control. And the same setup will also work in a packaged build. At this point, an important question arises. How can this system work consistently across different data types when each one has different value ranges? For example, the Lumia level sequence actor requires normalized values, so that the timeline length remains flexible. And how do we stay adaptable without constantly rewriting logic? This brings us to the FlexGraph. This is where the real data processing happens. FlexGraphs are data assets that contain a node-based graph for transforming data. Here we can remap, reroute, or combine data channels. Let's open the graph. You can see how input channels are routed to outputs. In this example, MIDI data is remapped to normalized values. Currently, there is a limited set of node types available, including remapping via curves, mixing channels, and scaling values. More nodes are planned for future updates. Once a FlexGraph is assigned in the inspector, the output data field becomes available. This shows the transformed data after it has passed through the graph. This makes it easy to verify that everything behaves as expected. Finally, with method binding, we can send Lumia data to other actors. Any method that accepts an Lumia data packet struct can be bound and triggered. This was a brief overview of how Lumia consumers work.